Good morning, students. Yesterday we have seen about the physical properties of the non-metals. Where do non-metals lie in the periodic table? Where do we find the non-metals in the periodic table? So here are the non-metals. So which are the non-metals? This line it is there na. So all these are the non-metals. Carbon, nitrogen, phosphorus, oxygen, sulfur, selenium, fluorine, chlorine, bromine, and then down some more are there. This iodine and astatine, and all these are the non-metals. Not only this also, but they have the different color because they are inert gases, and at the same time they are also the non-metals, and also Nm means non-metals. Okay, so why do we say them inert gases? We will everything we study in this lesson. And this side all this color na, this gray color, all these are the metals, and this white color boxes is called as a metalloids. So these metalloids are separating the metals and non-metals, and about these metalloids also we will study in this lesson. Okay, so in this periodic table, as we are coming from left to right, okay, if we are coming to the left to right, what is happening? Metallic character is decreasing. Why? Because after the metals, what is starting? Non-metals are starting. That is why when we are coming from the left to right, metallic character is decreasing. But when we are coming from top to down to the group, so non-metallic character is increasing. Okay, because if you see this down, all these metals, so when we coming from top to down, metallic character is increasing. When it's going left to right, metallic character is decreasing, because after the metals, non-metals are starting. That is why. Okay, so this is the one of the property of the periodic table. What is that property? Metallic character, when we go from left to right, it is decreasing, because after the metals, non-metals are starting. When we are coming from top to down, metallic character is increasing, because all the metals are only present here. Okay, so that is the why. So if you are coming like this also down, here non-metal is there, here metal is there, here also non-metal. So that is the why. Okay, so here we will study. So how many non-metals are there? Everything we will learn. So let me read line by line. You follow the textbook. Can you tell whether an element is a metal or non-metal by looking at its position in the periodic table? We know that as we move from left to right in periodic table, there is a decrease in metallic character. Now I explain that as the group number increases, the metallic character decreases. If we look at the elements of the first group, then we find that all its elements except hydrogen are metals. But we will not find a single metal in the elements of group 18. If you look at the elements in a particular group, then there is increase in metallic character as we go down the group. For example, if you take group 15, the first two elements are, okay, please, I will, once you see the periodic table, which is in the lesson, fourth lesson, just take that page, periodic table. Okay, so in that periodic table, when we see left side, the first one is present what? The first one is present the hydrogen. Okay, so let me take that page and explain to you just for 1 minute. Okay, so if we see in this periodic table, we will see now you see the first one is the hydrogen, but it is what? It is the non-metal. All other things are what? Metals. Okay, everything is the metals. So that is why when we say, when we are going down to the group, these are the groups, na? So when we are going in the group from top to down, it is the what? Metallic character is increasing. When we are going from left to right, so left to right means, you see, when you are going to the left to right, metallic character is decreasing. Why it is decreasing? Because afterwards non-metals are starting. So now you see, when we go down the group, metallic character is increasing, metals and this non-metal. And only in the periodic table, this is the left side. This left side, what is present is hydrogen is present. Okay, so among the non-metals, which non-metal is present left side? In the left side means hydrogen. All other non-metals are present in the right side. Okay, see here, all the non-metals are present. All these non-metals are present in the right side. Okay, now we will come to our lesson. Okay, so we have seen now. So for example, here everything they are explaining, we will see. So first group, if you look at the elements in a particular group, then there is an increase in the metallic character. Okay, if you take 15 group, then the first two elements, nitrogen and phosphorus, are non-metals. The fourth and fifth metals, arsenic, antimony respectively, of group 15 show some metallic characters but are not completely metal. However, the last number of the same group is a metal, bismuth. And there are some properties that are exhibited only by metals, while there are other properties that are shown only by non-metals. However, we also find some element that shows some properties of metal and others non-metal. That is, their properties lie somewhere in the middle. In the periodic table, these elements are located between the metals and non-metals. That is why we don't see a sudden change in metallic group. As we move from one group to the next, the change is stepwise. This behavior is seen in the elements situated along zigzag diagonal in the line. Okay, so when we take this periodic table, about this they are explaining about the metalloids. So this is like zigzag line separating the metals and non-metals. Metalloids means what? They are called as semi-metals or metalloids. They have the properties of the metals and also the non-metals. That is why they are placed between the metals and non-metals. So these are the metalloids. So and another name we call it also semi-metals, because they have the properties of the metal and also the non-metals. So metalloids are also found as solids. Boron and afterwards is what? Boron and silicon are poor conductors of electricity, but addition of impurities leads to electrical conductivity. Addition of impurities means, if the boron and silicon, this single element, if it is not mixing with another element, it is called as a pure. If it is mixing with another element, it is called as a impurity. Okay, impurity means not dirty here. Impurities means it is adding to the other element. So now we cannot see the boron. Now two elements are combined. When boron and silicon is combined with another elements only, so it can conduct the electricity. But otherwise, boron and silicon are the poor conductors. All elements that do not belong to metals and metalloids groups are called non-metals. So these non-metals are not belong to metalloids or metals. So these are called as a metals. Non-metals. Okay. So here non-metals include one member carbon of a group 14, 2 members nitrogen and phosphorus of group 15, and 3 members oxygen, sulfur and selenium of group 16. Group 17 is known as the halogen group, and 5 of its members, fluorine, chlorine, iodine, bromine and acetine, are non-metals. Since halogens require only one electron to complete their octet, therefore they are very reactive. They are not found in the free state in nature and were recognized only near the end of the 18th century. Okay, so here these elements are found only near the 18th and the end of the 18th century. So in the 14th group, one metal is the non-metal is carbon. In the 15th group we have nitrogen and phosphorus. And then in the 16th group oxygen, sulfur and selenium. And in the 17th group fluorine, chlorine. Okay, 17th group we have fluorine, chlorine, bromine, iodine and arsenine. This group is called as another, they are non-metals, but also we call it as a halogens. Why we call them as halogens means, because now if you see chlorine atomic number is what? 17. So what is the electronic configuration? 287. So to become it 8, to fill their octet, so it need only one more electron. So it will become now 8. So that is why halogens, why do we say them means to fill their octet like this, na? So here 2 are there and here 8 and here only 7 are there, but we need one more to fill this round, to fill this octet. That is why we call it as a halogens. All these halogens need one electron to fill their octet. So that is why they are more reactive. So this group elements is called as a halogens. And then one more thing, but the halogens are found out at the end of the 18th century and they are not found in the free state in nature. Group 18 consisting of noble gases is a big group of non-metals. It includes the colorless gases helium, neon, krypton, argon, xenon and radon. Since the outermost shells of the noble gases have 8 electrons, therefore they do not normally take part in chemical reactions. They are also known as inert gases due to this lack of reactivity. Since they are found in the trace amounts in the atmosphere, they are called rare gases as well. Can you think of any element which is a non-metal but which has been placed in the left side on the periodic table? Before we study more about non-metals, let us read a little bit about their history. All the non-metals are present in the left side of the right side of the periodic table, but one element is present in the left side. It is called as a hydrogen. Hydrogen is present in the left side of the periodic table, but it is also the non-metal. All other non-metals are present in the right side. So in the 18th group, when we see, this is the 18th group, na? This helium, neon, argon, krypton, xenon, radon. All this 18th group is the non-metals, but we also call them as a inert gases. So why do we say them inert gases? Because their outermost shell is filled. For example, helium atomic number is 2. In the first shell we should have only 2, and then neon we will take. Neon is the 10. So electronic configuration is 2, 8. So when we take here 2 and here 8. So always the outermost shell is filled. Since the outermost shell they have the 8 electrons, they will not react with any other element. That is why we call them as the inert gases. Why these 18th group elements are the non-metals, but another name we call it as inert gases, because their outermost shell filled with the 8 electrons, so that they do not react with other elements. That is why we call them as a inert gases, and they are very less reactive because their outermost shell is filled. They are less reactive, so we call them as inert gases. This 17th group non-metals we call it as a halogens, because to fill their outermost shell they need only one electron.